you can just find it out that what are the companies that makes microcontrollers based on the ARM architecture. So this is the ARM architecture, as you can see from the first TSMC. So India has recently tied up with TSMC. The TSMC Taiwan Semiconductor Corporation, TSMC. So it is next to Foxconn. Foxconn is the world's largest manufacturer of electronics. I mean the conductors, and the iPhone is also made by Foxconn only. So the next company to Foxconn in Taiwan, it is TSMC. So India has tied up just 1 year back with TSMC to manufacture semiconductors in India. So ARM is in partnership with these companies: TSMC, Motorola, Vijara, IBM also, Sony, Philips, all these. Intel also. Even Intel also. Okay. Now what happens is, you see, there is a name and there is not a name mentioned there. See, Apple is there, right? Apple is there. Can you see Apple? So you are using Arduino, right? So that is the Atlas 382P microcontroller. This one is Atlas. Here. This one, Atlas. Okay. So the Arduino that you are using, so it is using this Atlas 328P microcontroller. Understood? So this is a very less powerful microcontroller. Very less powerful. You can use this kind of this. This Hyundai. This is a car, company, but now it is also making microcontroller. So these things you should know before you get into making your own smartwatch, because you have to find it out, that which to use. Now there is one company which is not mentioned here. Of course, I mean there are more than 200 companies tied up with ARM, and ARM is the world's largest architecture making company. And you see that company name is the STM Electronics. Okay. So you can just pen it down. STM Electronics. You can just pen it down because you will need it afterwards. Means when you will make the automation system for large systems, so you will need that STM Electronics microcontroller. So you can visit the STM page also. Just you can write STM and you will get this STM Electronics. So this is the website. Please see the website because we don't have more time to discuss about these things. I'm telling these things because I don't know that when the next time we will come and we will be able to get you again, right? That is why I have to deliver everything fast. So you see, with the tools and the softwares, if you go, so there you will find all kinds of tools. These calculators, simulators and models, developmental tools, the ecosystem, the embedded software, simulation tools, all these things you will get. You can go to application and see automotive motor control. Okay. So if you go to the motor control, mainly this thing is for the mechanical engineers. So here they will tell you that which one to select for this motor control and all. You see automatic blast, DC motor, automatic BLDC motors, automatic bipolar stepper things and all. Mainly for the mechanical engineers, I'm telling you. Now coming back to this thing, you can do what? We were in the topic of making a smartwatch, right? So coming back to the topic, so the microcontroller should be selected by you only. So you can use the STM32F401RE. This microcontroller can be used. This is my suggestion. You can choose anyone, but you have to choose a microcontroller which is at least of 64-bit. Otherwise, nowadays, if you say to write an operating system of 32-bit or 16-bit, then it will take approximately 60 years to write an operating system. That means your kids will complete the course. Understood? You will start to write, you will eventually die, and someone will come. I think he will also be, he will also be not able to complete. Your grandchildren is going to complete their operating system for you. So you can use the STM32 401 RE. Now the problem is where if you go and buy this recommended board, so it is going to give you something like this. The microcontroller is here and all the pins, all these things are here. So you optimize that PCB in certain extent so that it becomes in this much area. Right? Let us go to the internet or you can search by yourself. Board of the STM, sorry, of a smartwatch. You will see that how optimized it is. Optimization is more important than innovation. So you see this kind of motherboards are there in a smartwatches. These kind of boards are there and which are highly optimized. So this is the real embedded systems I was talking about. Very, very optimized. Very optimized. You see, this is the board of a smartwatch. Nothing is hanging. You can just have the lesser size of this particular one also. So this is the thing you are actually going to make. But for that you have to design the PCB. PCB is what? The printed circuit board, right?
Yes, sir.
Those who don't know, to them I am telling, it is a printed circuit board. IIT BHU has got machine of this printed circuit board to make PCBs. Okay. So use the resources to make the things. Otherwise, what is the use of the resource? So this is the board, or this kind of board you are going to build for your smartwatch. Now you try to imagine not only smartwatch. Suppose you want to make a watch that can control your whole system. So this means just I'm going a bit fast maybe, but just imagine the solutions and the problems. The professors, they can have a different kind of smartwatch, which is not a smartwatch. Actually, this is a smartwatch which can control all the rooms of IIT BHU, all the lecture halls and the seminar halls, right? So they can see that I have to go to the room number 13, right, to teach the students, and so the room temperature is now 28 degrees centigrade, which is not good. So from here they can just turn on the AC, and they can set a timer or an alarm here that when the temperature is below 25 or 20 degrees, just let me know. So it will beep, like it will beep, and the professor will know that yes, now inside the room no dust is there, and the students have arrived, and the temperature of the room is okay, everything is okay. So he can come and take the class. That will be much more efficient. Also, many lecture halls there are lights on, right? So they can simply figure it out that the lights are on in 5 rooms, which is not needed now, right? So they can just turn it off. Understood? Just to give you the idea that how efficient it can be if we can use IoT and embedded systems, in a good way. So you can see that board. So you have this microcontroller, you have this display controller, you have all these things like all the peripheral chip and everything is there, right? So many sensors are there. But you see the sensors are also so optimized you cannot see the sensor. Let me tell you one thing, 99% of the smartwatches available in the market do not have sensors. They claim to having sensors inside it. They don't have sensors. So it may be one of them, and that's why you cannot see any sensor here. There are actually no sensors. To make this board, it will cost around $1 or maybe 80 rupees, 70, not even that much for a company. And these companies are selling these watches to you with a price of like 10,000, 5,000, around that. So the last thing means we will now get into the technical hardware. Before that, I just want to ask you one thing. Just answer me with yes and no. Can this machine or this board measure your blood pressure?
No.
Yes or no?
No, sir. No.
The answer is absolutely no. There is no physical arrangement which can measure your blood. Even your heartbeat sensor is not also accurate. If you actually have to measure, just you tap in this vein, okay, and you just figure it out that the normal is 72 BPM. If you run and all, it can go up to 120 BPM. And if it is lower than 30 BPM, so you are dead. And so you will be unable to figure it out also by yourself. And also, if it goes beyond 200, so you think that after two minutes you are going to die, so you can call your mom. So this is the microcontroller you can see. Now what will happen is STM32